Good morning, students. I'm going to go over the Unit 8 test here. Several of these problems seem to be trickier than expected. So I'm going to quickly go over every single problem in anticipation for a very small extra credit assignment that I will offer during finals week. Got a bad case of bedhead here. Oh, well, you'll put up with it. Alrighty, friends. So for right here, graphing of a line, we add 3, and of course we get x equals +1. That's all the points where x is 1. So it looks like this. You're at 1, and it is all the points. So that's 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and all the points where x is 1 looks like this. Of course, graphing of lines. This is a really important skill. The goal is to get y by itself. So we're at -32. I have 6x minus 4y equals -24. And of course, we minus 6x. I got -4y equals -6x minus 24. Divide by -4, -4, -4. Really important. A few of you, double negative makes a positive. So that's going to be y equals 3 over 2x. And -4 there. That's going to be +6. So we're at the 6. It's a positive line going up from left to right. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. And there was your line. Equation of a line, most of you did really well on this. You start with what you have, c equals d pi. So we solve diameter equals 8, radius equals 4. And the center is going to be 0, 4. So x minus 0 is simply x squared plus y, double negative, minus 4 would be +4, parentheses squared, equals 16. And it looks like this, 0, -4, and 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Arc length is fraction of circumference. Sector area is fraction of area. And in this case, for this example, this was 210 over 360 times, some of you didn't trace all the way across, that's 36 inches pi. This would be 210 over 360 times 18 pi. And then you just reduce the daylights out of stuff. All right, the 36 cancel. This one was 21 pi inches. Kill the zeros. 18 goes in here twice. 2 goes in there 9 times. 9 times 21 is 189 pi inches squared. Find all possible arcs and angles. So we start with the on, and this would be half, 41. And then you have another on grabbing the same arc going this way, 41. And you should have noticed the diameter, which adds up to 180. Take away 82. Of course, this is 98. And you look for any inscribed angle that grabs that 98. And that's right here. So it's 49. And then that's it, friends. There's no more you can do there, because those of you who put angles here in the middle, that is not a central angle. So you cannot do central angles equal the arc there. And this is not a diameter. So those of you who treated that as a diameter, okay, and you went like this and found that as 98, you can't do that because that wasn't a diameter. All right, so the trick to this whole problem is you have to get your fingers on the diagram. And from here to here was 3. And since that was a radius, it's also the same from here to here. 3. And if that's a sphere, we can rotate that 3 this way. 3. So your volume equation for a sphere, this is half a sphere, so your volume equation for half a sphere would be 4 pi r cubed over 3, and then you had to divide by 2 there. So it would be 4 pi 3 times 3 times 3 over 6. And then this down here, volume equals base times height. That's a cylinder. Our base here is pi r squared, and our height is here. And this is where some of you had trouble. You just assumed the height was half of the 7. It's not. If you get from here to here is 3, and this is 7, your height there is 4. And so this would be 3 squared times 4 times pi. You would go through both of those and add them together. And you were supposed to keep it in pi form. This one's super important. When you change dimensions, you change ratios. So right off the bat, first dimension is x to the first and y to the first, x to the second, y to the second, x to the third, y to the third. And you must align your units there. And in the first dimension, there is 100 centimeters for 1 meter. So your first order of business is to get the 300 meters into centimeters so you can get them in the same unit. And so we're going to do 300 times 100. And that's 1, 2, 3, 4. So 1, 2, 3, 4. And that's 30,000. So it's 12 cm to 30,000 cm. But wait, there's more. You have to reduce that. So we're going to do 30,000 divided by 12, and you should have gotten 2,500. So your first ratio here would be 1 to 2,500. Second one is 1 squared to 2,500 squared. Yes, you should have worked those numbers out. I'm just going kind of quick here. And volume would be 1 cubed and 2,500 cubed. When you change dimensions, you change ratios, but you have to get things in the same unit. I think on one version I changed this to 288 pi. So you start with what you have, not with what you need. So the volume of a sphere is 4 pi r cubed over 3, and that is equal volume. But in this case, our volume was 288 pi, and we had 4 pi r cubed over 3. So some of you forgot to put it over 3. Some of you forgot the next step. And the next step was simply to pop this over 1, cross multiply, and solve. And you would have gotten r cubed equals 216. And then you ask yourself, What number times itself 3 times gets you 216? And that is 6. And then you find the surface area, which was 4 pi r squared, is your surface area, keeping it in pi form. All right, this is a pyramid, and a pyramid, volume equals base times height over 3. So your base was a square, so it was simply 8 times 8. This is where some of you didn't trace. You used your eyeballs. You didn't physically trace that height. Height always makes a right angle straight down to the base. So you had to solve for that height, which means you had to use Pythagorean theorem. So in this case, it would have been x squared plus and trace, that's 4 squared equals 10.8 squared. You solve for that x, which is your height, and pop it over 3. All right, so when you deal with a net, the easiest way to do this is pretend like that piece of paper is in your hand and you fold it into the net. And if you fold this, you fold down the 2 triangles, you see that you have a prism. So I'm going to start by drawing those triangles. So there are my bases, and there's 2 of them. And I squished them sideways a little bit to make it look 3D, and there were right angles there. This was 3, this was 5. And pull it down. And this edge here was, of course, 8. So your equation here was volume equals base times height because it was a prism. Your base is a right triangle. And a right triangle is leg times leg over 2. And you needed to recognize that you had to solve for a leg here. So that'd be 3 squared, x squared equals 5 squared. Solve for that leg. X equals square root 25 minus 16. Excuse me, 25 minus 9, which is 16. I'm a goof. And square root of 16 gave us 4. So your one leg was 3, your other leg was 4 over 2. All of that was your base, and your height is always the distance between the bases, 8. And should have got 48 cm cubed there. This one, we start with the scale factor. Scale factor is the ratio of the sides simplified. And we already have the scale factor right there. It's 5 to 8. That's the first dimension. Then we go to the second dimension, square it, 25 and 64. And then we go to the third dimension. 5 times 5 times 5 is 125. Ooh, 8 times 8 times 8. It's 500 something, but let's see, 64 times 8, that's 2, carry the 3, 48 plus, 512. So 512. Then realize this is 1D, 2D, 3D. It says the volume of the right cylinder is 2048. Find the volume of the left. So instantly I know I'm in the 3D ratio. And when you make your ratios, I always label them left to right, left to right. Always label everything. So I'm in the 3D ratio. So 125 to 5, 112. And then this is the right. So that's 2048. And then here was your X. cross multiply, solve. Here it says the surface area. Instantly, I know I'm in 2D. And I'm working left to right, left to right, left to right. And the cylinder on the left, so now I'm in 2D, 25, 64, left 150, cm squared, right is x cm squared. Cross multiply. You have to align the ratios with the dimensions that you are in. All right, your job is to find the area of the shaded region, which is right here, all of this in exact radical form. And geometry is all about the shape. So honestly, the most important word here is equilateral triangle. All three sides are equal. If all three sides are equal, all three angles are equal, which means 60, 60, 60. In this case, we were given the radius, and careful, it was the radius of the circle. Right here is 6 inches. Your goal is to find the area of the shaded region. We're going to make an icon equation. We're going to do triangle, and it is minus circle. Triangle. Because it is equilateral, it qualifies as a regular polygon. So I could have done perimeter times apothem over 2, area equals, or area equals base times height over 2. Of course, area of a circle is pi r squared. This one, we already have everything we need. Square the radius, 36 pi. Let's take a look over here. We have our apothem. That's 6. So all we need for that part is the perimeter. What you needed to recognize right here is you had a 30, 60, 90, short leg root 3, short leg times 2. So 30, 60, 90. Short leg to long leg, root 3, short leg to hypo times by 2. So this becomes 6 root 3, which means my entire side length. So that is the version of this, PA over 2. I'll do the other version, this one right here. You take a look, you have your base, which would be 12 root 3, and you're like, well, I don't have my height. And several of you were like, I don't have my height. Well, if you got your fingers on the diagram, my friends, you would have recognized that this piece here is the exact same piece there, which is 12, which means our height, therefore, is 18 over 2. Either way, you could have gotten the exact same answer. 2 goes into 6 3 times. So that's 9 times 12, 18, carry the 1, 108, 108 root 3. This one, 2 goes in here 9 times. Again, still 9 times 12, 108 root 3. So the exact radical form here was 108 root 3 minus 36 pi inches squared. Then you just use your calculator, get the decimal version, and the percentage was approximately 40% here. Okay, in this storyline, we essentially have two solids. We have a pentagonal solid, pentagonal prism. I'm going to draw that one. And we have a cylinder. And both of these are volume equals base times height, and volume equals base times height. They're the exact same equation. Let's see what you were given. You were given the height of the grip was 30 millimeters. And you were also given the fact that the diameter of this, okay, from edge to edge, is 10 cm, which means the radius is 5 cm, which if you draw it like this, that also gets us our apothem. So this would be simply pi r squared. So 5 squared pi times 30. I'll just leave that there for a moment. This one, you had to find the area of that pentagon. And I'm going to pull it out here. You had the apothem. The apothem was 5. And perimeter times apothem over 2 would give you that area. So what you were missing was this perimeter. So you needed to draw, you got a right triangle there. You need to draw this in here. Make a right triangle, because the key to everything in geometry almost is a right triangle. I'm losing my son here. Let's scoot back over. So you had to draw in your pizza slices. And that was 360 divided by 5, which is 72. And right there is 36. Let me go ahead and pull that out. 36, 5. And you want to find this little piece right here. So we have the adjacent. You need the opposite. And that's an OA. So it's tangent. It's TOA. So it would be tan of 36 equals our opposite. I'm going to call that X over our adjacent, which is 5. Cross multiply. So that's going to be 36 tangent times 5, 3.6. I'm going to round to that first decimal, and then you had to double it to get the full sides length. So 3.6 times 2, 7.2. So back to our diagram here. This right here would be 3.6. Our side length is 7.2. So our perimeter is going to be 7.2 times 5. That's our perimeter. Our apothem is 5 over 2. All of this is going to constitute the base here. And then your height is still 30. And you get those two numbers and you subtract. I'm not going to do that math, but what you needed to hear, the trick to this problem was converting millimeters squared into centimeters squared. So when you change dimensions, you change ratios. And if you know 1 centimeter in the first dimension is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 millimeters. So in the first dimension, okay, 1 cm is 10 millimeters. In the second dimension, 1 cm, technically that's squared. And then 10 times 10 is 100 millimeters squared. So 1 cm squared equals 100 millimeter, and then 3-dimension, 1 cm cubed. 10 times 10 times 10 equals 1,000 millimeters cubed. And that is the conversion factor you should have used.